we're going to go over pH calculations of Bronsted-Lowry acids and bases. So according to the Bronsted-Lowry definition of an acid and a base, acids are hydrogen ion donors, like this. So the HCl has donated a hydrogen to the water to become hydrogen ion, and chloride bases are hydrogen ion acceptors. So the ammonia has accepted hydrogen off the H2O. We've got ammonium ion and hydroxyl ion. So we're going to be using this principle to apply it to the following examples. So the pH scale is used to indicate the acidity of a solution between 0 and 14, acid to alkali. So pH of 0 is very acidic, pH 14 very alkali or base, and a neutral solution has pH 7. So pure water is pH 7. We calculate the pH, it's on a logarithmic scale, so you calculate minus log base 10 of the amount of hydrogen or hydrogen ions. You can do the same with pOH, the same equation, and we know that pH plus pOH gives you a total of 14. So we know strong acids and bases 100% ionize an aqueous solution. That means, for example, in this case, the hydrogen and the chloride ions dissociate. They all dissociate because it's a strong acid. So if we do some examples, so calculate the pH of 1 times 10 to the minus 2 molar solution of hydrochloric acid. So we know that hydrochloric acid is a very strong acid, it's stomach acid. So to calculate pH, we had the equation pH equals minus log base 10 of H3O plus. So if we look at the formula for HCl, we have H and Cl minus. So to calculate the pH, minus log 10 of 1 times 10 to the negative 2, because the hydrogen and the chloride ions 100% dissociate, which means the concentration of hydrogen ions is the same as the concentration of the solution. So we get a pH of 2, which is very acidic. So next example, calculate the pH of 1 times 10 to the minus 3 molar solution of sulfuric acid. Sulfuric acid is also very acidic, but this example has a slight twist to it. So we have the same formula, and sulfuric acid is also very strong, so it will 100% dissociate in solution as well. So pH equals negative log 10. But if we look at this, the formula for sulfuric acid, the hydrogens, there's 2 lots every time it dissociates. So the concentration of hydrogen ions is actually 2 times the concentration of the given solution, because in the solution 2 hydrogen ions dissociate for every molecule of this. So it will be 2 times 10 to the negative 3 of hydrogen ions specifically, because that's the measure of pH. So pH will be minus log 10 2 to the negative 3. So it'd be 2 times 2.70 as the pH. If we do one more example, so it says calculate the concentration of nitric acid with pH 1. So you're already given the pH, but if you didn't know already, nitric acid is also a very strong acid. If it's a weak acid, there'll be another video on that, but it involves the acid dissociation constant, which is a bit more difficult. So it says calculate the concentration of nitric acid with pH 1. So nitric acid is HNO3 we have hydrogen and we have nitric ion. So it only has one hydrogen for the molecular formula. So we already know that the equation is pH equals negative log 10 H3O plus. And we know the pH is 1 already. So if you know how to work with logs, you basically know that, say, if it was in this arrangement, it would be a to the power of b equals c. That's another way on how to get it. So if we rearrange this, we know that 10 to the power of negative 1 will give us the concentration. Right? So we multiply both sides by minus 1 to get minus 1 and log 10 of the hydrogen ion concentration. And then we've flipped it using this rule as part of logarithms to have it in this form where we have an unknown by itself. So now since we've got that, just put it in the calculator. So the concentration of nitric acid is 0.1, and that'll be in moles as well. A molarity or moles per decimeter cubed. And that's it.